Hi students, how are you? I hope you and your family members are safe. Okay, today we are going to study and I'm going to explain about how to find the number of isomers. Okay, so by this class, at the end of this class, you will be knowing to find how to find the number of isomers and by using all simple tricks. Okay, shall we start the class? Okay, before going to learn how to find the number of isomers, before we need to know what is an isomer. What is an isomer? Isomer is having same molecular formula but different structures. What? Same molecular formula but different structures, right? So we are finding out these isomers for structural isomers. For what? Structural isomers. Okay, so before going in deep into finding out the number of isomers, these structures will be written, actually the structures will be written in three different forms. That is expanded form. What? Expanded form. Next one is condensed form, right? Condensed form. And next is line form, bond line form, bond line form. Okay, so with the help of these three, the structures of an isomer is being determined. Okay, so we'll first take, we are finding out this isomers first for alkanes. For what? Alkanes. So what are the root words for alkanes? As we know, the root words for alkanes are meth, methane, ethane, propane, butane, and so on, right? There are other alkanes also. So by taking each and every one example, we will be finding out how this expanded form, condensed form, and bond line form has been written. Okay, first one is expanded form. So we will be taking with the help, first we'll start with methane. Okay, so methane, what is methane? Meth means what? One carbon, right? Ane means single bond, that is carbon. So what is first you need to know what is the valency of carbon? It is 4. So valency of 4 in the sense that means whenever it is surrounded, the carbon will be surrounded with 4 bonds. Okay, carbon should be having 4 bonds, right? So here carbon is there, methane, that is surrounded with 4 bonds. Okay, so this is what, here it has been balanced with hydrogen. I am writing hydrogen. Okay, so this is the expanded form. If you go, this is expanded form. If you go with condensed form means you are condensing these all forms. So CH4 is the condensed form. And next is line form. Line, just for suppose the line is there. This is a line. Here you are having 1 point. Here you are having 1 point, right? So these points define you the carbon. Okay, so here you are having only 1 carbon. So this is what the bond line form. Okay, I hope you understand, right? So next I am taking another example. Again, I am taking another example of ethane. Ethane means what? 2 carbons, right? Carbon, carbon. So in between carbon, carbon, what do you have to have the bond? Ane is there, so single bond. So as for this carbon, you are having 1 bond. So the valency of carbon is 4. You need to require another 3. 1, 2, and 3. Here it is 4. For this also 1, 2, and 3. So here with hydrogen, here with hydrogen, here with the hydrogen, 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 and hydrogen. So what is this form? We call it as expanded form. Right, and next condensed form. So that means you are condensing the structure. So what happens? CH3, CH3, or you can either write it, this is the condensed form, and you can either write it as C2H6. This is the condensed form. So what will be the line form? As if I told you, a line defines you the two carbons. So here one carbon is there, here one carbon is there. So if you're here one bond in between carbon, this bond is there. So it is ethane. So here you have to think, you have to imagine that here is a carbon with three hydrogens. Okay, so now did you understand what is expanded, condensed, and bond line form? So now we will be actually going into the concept and how to find out the number of isomers. Okay, so as we are having the root words, that is methane, okay, so as we are having the root words, that is methane is there, right? And next is ethane, next is propane. First we'll see for these things. Okay, so methane, as we know, carbon, carbon, carbon. Here one hydrogen, 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 and hydrogen. So this is only the formula is C4, CH4. The only structure it could be formed for methane is only this. So what is the number of isomer? 1. Okay. Next, if you go for ethane, so ethane is C, C, H, H. Here also hydrogen, here also hydrogen, here is also the hydrogen and hydrogen. So this is C2H6. This is only the structure it could be formed. There is no different structures can be formed for ethane. Okay, so how you can only how many isomers? One isomer. If you write for propane, that is what? Prop means three carbons. In between carbon carbon you are having single bond because ane is there, that is alkane. So how do you have hydrogen, hydrogen, hydrogen? So here carbon two bonds are there, as its valency is 4, you need to have another two bonds, that is hydrogen, again hydrogen, hydrogen, and hydrogen, right? So how what is the structure? C3H8. So for propane also it could be formed only one isomer. Okay, it could be formed only one isomer. Okay, so next is what? Next here comes the butane. What? Here comes the butane. Butane means what? Four carbons, right? Butane means four carbons, carbon, carbon, carbon. So how you will be writing? Hydrogen, hydrogen, hydrogen. Here also hydrogen. Here is also hydrogen. Here is also hydrogen. Hydrogen, 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 and hydrogen. So now what I am doing is, now we have to find out the butane isomers. Okay, so how we can write it this in the bond line, as we are having four carbons, right? So one, so you can write it as 1, 2, 3, and 4. So what? 1, 2, and 3. This is the bond line structure for butane. So this is what. And next, what is the isomer for this? So I am taking out this carbon, this bond, and I am writing like this. So what is having? Here also four carbons, 1, 2, 3, 4. Here also four carbons. So that means the molecular formula is same. Molecular formula is same, but structure is different. Structure is different. So is this two are the isomers of butane, right? So how many isomers you are having? Two isomers. Okay. So let's take another example. What is an example I am taking again? Next I am taking pentane. Pentane, right? So pentane means what? How many carbons you need to have? 5 carbons. So 1, 2, 3, 4, and 5. So how you can draw? 1, 2, 3, right? In between 4 bonds. So how you will get the isomers for this? I'm taking out this bond. So no two structures should be same. Okay. So the point you have to remember is no two structures should be same. Then only you can count it as an isomer. Okay. Okay. So for this, how can I write 1, 2, 3? Okay. This is one isomer. Okay. So here I am keeping one bond. Again, this I can write it as 1, 2. So one bond, one. So total how many are the 1, 2, 3. So here one carbon, another carbon, another carbon, another carbon, another carbon. So 5 carbons are there. Here also 1, 2, 3, 4 and 5. Here also 5. So here is also 5. So these all are the isomers of pentane. These all are the isomers of pentane. So how many isomers are there? 3 isomers. Okay. So now let's find it in a simple way to remember. Okay. For suppose here here we are having one isomer, right? So if one carbon is there, how many number of isomers you can form? One. Two carbons are there. How many number of isomers? One. 3 carbons are there. How many number of isomers? 1. Okay. So what? 1 isomer. Okay. 1. And next here 4 carbons are there. Number of isomers can be formed is 2. If 5 is there, it's 3. If 6 is there, 7, 8, 9 and 10. How do you find out for all these? How do you get the number of isomers for all these structures? Is, okay, you have for all these till 7. Okay, the formula for this, the simple trick is 2 to the power of n minus 4 plus 1. What? 2 to the power of n minus 4 plus 1. So first, for suppose we'll just check it by taking 1 as example. First, I'm taking n is equals to 1. So 2 power n minus 4 plus 1 means what? That is equals to 2 power 1 minus 4 plus 1. So what you will get? 2 power minus 3 plus 1. As this is negligible, we will be taking as 1 only. So random, I am taking n is equals to 5. So that is 2 power n minus 4 plus 1. That means 2 power 5 minus 4 plus 1. Right? 2 power 5 minus 4 is what? 2 power 1 plus 1. That is equals to what? 3. So is it correct here? 3. So n is equals to 6. 2 power 6 minus 4 plus 1. That goes as 2 power 2 plus 1. That is equals to 5. So that means what you will be having here? 5. So next n is equals to 7. So 2 power 7 minus 4 plus 1 is equals to 2 power 3 plus 1. That is equals to 2 power 3 means what? 2 into 2 into 2. So 2 2s are 4, 4 2s are 8. 8 plus 1, 9. So how many isomers are there here? 9 isomers. Okay. So if you go for 8, so till 9, till 7 carbons are there. These are the number of isomers. What? Number of isomers. Okay, so that is number of isomers. Till 7, this is what? The isomer. Again for this, the formula will be 2 power n minus 4 plus 2 and 2 power n minus 4 plus 3. Okay, for this if you won't remember, you can write it as 2n plus 2, or you can either write it as 4n minus 1. Any of these two formulas are fine. So here how many number of isomers? 18. For here 35. So to find out number of isomers for 10 carbons, number of carbons, number of isomers. So if you add all these, you will be getting a total. That is the isomers of 10, that is 75. Okay, so now is it easy to find out the number of isomers for n number of carbons, right? I hope you understand this video and it is very useful and it is the most important concept which you have to be learned for the entrance exams. Thank you, students. Hope you do well and be safe.